Welcome to an example in which they're giving us a function. Whoops, sorry about that. They're giving us this function. Oops, my pen is not working. There you go, right there. And let me bring it down here. They want us to take the derivative of it. So tan inverse of, put this in here, 6 sine I'm trying to show you the layers here. Okay, it's 3 layers. All right, so let me give you the rule. So first off, um, how do we take the derivative of tan inverse? What is the derivative rule for tan inverse? It's same as arctan. Tan inverse is arctan, whatever. Say or arctan. The derivative is, sir, it's 1 over 1 plus x squared of x, or tan of x. Okay, so here we go. So we're going to go derivative. Okay, now what about that 7 sitting in the front? Remember, numbers multiplying in the front of a function. They just sit there like a spectator, not doing anything. Times. Now, how do we do the derivative? Now, notice the layout. We have a function, and then inside of that we have a function, and then inside of that we have a function. It's triple nested functions. Now, that requires the chain rule, right? So it's right here. Functions inside of functions must use the chain rule. Okay, so how do we do it? This is 3 layers. So let me give you a 3 layer one. So if you have like, I'll just call it F on the outside and then G on the inside and then H inside of that. That's what we have basically. F, G, H. I'm trying to use the same colors to make it easy. This is F. This function here is G. And this function here, in fact, let me just do it all caps. I just want to make it really clear. Let me try again. So make it G and then H. Okay. So this is G and this is H. All right. So what do you do? Well, the derivative, what do? You do the outside layers. So that'd be F prime. And then you keep everything after that the same. So the G, the H, they just stay the same, times, and now you're done with that layer. Now you go down to the G layer. G prime, derivative of G, and you keep everything after that the same. H. And you're done with that layer. Times, and then the final layer H, H prime. So there we go. It's like links in a chain. That's what's called the chain rule, right? So you do the outer layer, then you do the one layer in, and then down to the final nested layer, like those Russian dolls inside of each other. And whenever we do the derivative of something, everything after it stays the same. So we do the derivative of F prime, everything else stays the same, then G prime stays the same, and then H prime. Okay, let's do it. So, so the outer layer, F prime, what's that going to be? Well, what's the derivative of tan inverse? Well, the derivative of tan inverse is 1 over 1 plus x squared. So I'm going to say, okay, here we go. I'm going to go. Wait. You know what? I really need some more room. Let me bring it down here. So F, whoops, it's on that setting. Here we go. So F prime, this is the derivative of x equals, so now comes the derivative. That up. All right, here we go. What is it? Well, the 7's just going to sit in the front. Times 1 over 1 plus, now x squared, but, right, that's what the formula says, but that x is just holding a place. Remember, in all math science formulas, when they, like right here, when they give us a formula, they say tan inverse of x, and the derivative is 1 over 1 plus x squared. That means whatever is in here ends up there, right? So you could put anything in there. And what have they put in there? They put this whole thing in there. So that whole thing goes right here, squared. Is this making sense? This is going to be 6 sine 4x squared. Well, that can be a little confusing. Is that making sense? I'm hoping. So that's the first step, right? That's the derivative of the outer layer. It's the 7 just sits in the front, and then tan inverse is 1 over 1 plus whatever you have plugged into tan inverse squared, right? That's what this says. Tan inverse of x, derivative is 1 over 1 plus whatever you have plugged into the tan inverse squared, okay? Now we keep going. So that outer layer is done. Now it's g's turn. Times, right? Because next comes g. We did this. Now we're here. The derivative of 6 sine. So the derivative of 6 sine 4x. Well, how do you do that? Well, again, the 6 is just a spectator. Whoop, wrong color. It's just sitting there. It's not doing anything. Now, derivative of sine, is cosine. You keep the 4x the same. Whatever comes after, you keep the same. Done. Done with that layer. We did the 6 sine. The derivative is 6 cosine of 4x. Last layer. Now, it's because again, you might wonder, why aren't we just done right there? Well, because the inside function is not a simple x. Let me highlight that. Not a simple x. Instead, it's 4x. So, if this had just been a simple x, then I'd be done. I would just say cosine x, done. But if the inside of anything is not a simple x, you got to do the next link in the chain. That's chain rule. Chain says anytime the inside of anything is something other than a simple x, if it's not a simple x, you better link the next chain, right? Chain rule. Chain rule link. Another link. So, okay, so what's the derivative of 4x? That's easy. 4. Derivative of 4x. 4. So, okay, now, honestly, you could just type that in. It'll take it. I'll clean it up a little bit if it's helpful to you, just to show you how they got the exact answer they got. So here we go for a little bit of cleanup. So I'm going to say, okay. So the bottom is pretty much as is, nothing really going on there. 6 sine 4x squared. So bottom. Now this guy goes to the top. So it's 7 times 1. And then this guy's all over 1 goes to the top as well, times the 6. I'm going to move the 4. This 4 in, right next to it as well. And then comes the cosine of 4x. I just want to put all the numbers together. And then one more step here. We can say, okay. This is 1 plus. Again, we're going to come in here and go 6 sine 4x. I guess I overdid the spacing there. Trying to get enough. Squared. Okay, and what happens on the top? Well, these guys multiply. 7 times 1 times 6 times 4. I guess that's 168. And then cosine of 4x, and we're done right there. We cannot cancel these 4x's because these are, you might say, well, it's multiplication, so you said anything multiplication. This is not multiplication, remember? Whenever you have a sine, cosine, or tangent, or any function, what comes in the parentheses after function is not multiplication. This doesn't mean cosine times 4x. That means plug in. 4x is plugged in. It's buried inside the toaster, so to speak, right? The 4x is plugged into the holes in the cosine toaster. So this 4x is plugged into the holes in the sine. They can't cancel. They're buried deep in those functions. No. We're done. And you can see, they pulled out the 36. You can do that or not. See how this 6 is squared. So if you want, you can make that a 36 in the front. It's good either way on that. And so that's how we do it. 84. So yeah, it is 168. Okay. And so there we go.